Alright, hey guys, welcome to another episode of Learn with Anirudh. And on this one, we are going to simplify everything there is that you guys need to know before getting started with this beautiful algorithm called as logistic regression. This is going to be a really interesting one. So, what are we waiting for? Let's get started. Okay guys, now just before we get started with logistic regression, I know you guys are super excited to get started with this. I already have a video up on linear regression, so if you haven't had a chance to take a look at that episode, the link is available in the description box right now. We're going to be using a bit of equations that we learned in linear regression. So if you haven't had a chance to take a look at that, do watch that episode. It's a very short and yet again a super simplified episode of linear regression. And once you're done with that, you can come back to watch this one. Of course, the link is available if you want. Now, anyway, I'll give you a quick recap of linear regression if you guys already know what it is. So let's just say that you want to spend an entire day at an amusement park. Now, you can get a machine learning algorithm to predict how much it is going to cost. Maybe you just want to take one or two rides. Maybe you want to do the entire routine of, you want to enjoy the next 10 hours of your day and you want to go on every single ride. So each of those ride will have certain costs, correct? So you can actually get your linear regression algorithm to predict how much it will cost depending on the number of rides that you want to go on whenever you want to spend a day at your favorite amusement park. This linear regression will answer. Now here's another question that linear regression can answer very easily is, let's just say you want to calculate the amount of fuel, you want to calculate the amount of price that you have to pay for fuel if you guys are planning a road trip, right? Now this always happens when you and your friends are taking your car out for a vacation. I bet a lot of you all will calculate the fuel prices, divide it among yourself and keep that budget separately, right? So you can actually get your machine learning algorithm to do it, and the algorithm which can do it best is really linear regression here. It can answer a question saying, if for 1 kilometer it costs you this much to go in your car per head, it can easily tell you what the predicted price is, considering that you guys are going 800 kilometers or maybe even more for you guys who are super adventurous that are out there. Okay, now this is good because we are trying to approximate the relationship that exists between two or more variables, and most of the time it's a numerical answer. What is the price of the amusement park? What is the price of fuel? So it's a lot of price prediction that happens with the case of linear regression. Now let's take a look at another example here. Let's just say that right now there is a hype for a brand new phone. I think all these folding phones are the ones that are going to be the thing of the future. So there's a lot of hype for a new phone and you want to buy this phone. You've made up your mind and you are looking forward to picking up this phone. So there's only two choices here at its absolute basic, right? When you think about it, you'll either buy the phone or you will not buy the phone. So it's just a simple yes or a no. Even though you might have spent months and months researching and weighing your options to see if you would buy or not, at the end of the day, it'll all come down to this question saying, do you want to buy it? Yes or no. If it is a yes, you're going to go to Amazon or wherever they're selling the phone, pick it up. And if it's a no, you're not going to buy it. Correct? But even though the answer here is very strictly binary, it's a yes or a no, if you realize we cannot use linear regression for this particular case. Linear regression will help you predict something. It'll help you predict a price. It'll help you make a continuous connection between variables. But here we want to find out, if we want to predict if this person will pick up the phone or not, whether it's going to be a yes or a no. So linear regression doesn't work for that. And of course, to step in and take the duty of even making sure we have beautiful predictions later in the day, we have logistic regression. Logistic regression, just like linear regression, helps us in making predictions. It is very good. It is widely used. And if you were to actually go and buy that phone that we just discussed, your credit card company would be using logistic regression and in that very moment that you made the transaction as well. Not just that, we're going to discuss a lot about logistic regression. An important thing you have to understand at this moment of time is with linear regression, no? The independent variable was mostly numerical, as we just saw, the price of the fuel, the cost of the ticket. Even in the example we discussed in the linear regression episode, we made sure to understand this completely. But what happens with logistic regression, you have to observe very closely, is that whatever we are trying to predict is not going to be a number, it's going to have a categorical nature for its variable. What do I mean by this? Will you buy the phone? The answer is yes or no. Will the person buy the car or not? Again, the answer is yes or no. Or what is the probability that a person will buy the car? You see that, right? The answer is mostly categorical in nature if you're doing a binary classification, and if not, you can still have predictions. Now, I know that you might have not gotten full clarity out there, so take a look at this. The answer to will a person buy the phone or buy a car is going to be either 1 or 0 at its absolute basic, like I just told you. But it can also be a fact that the answer can exist anywhere between 0 and 1. Now, how do you go between 0 and 1? Let me tell you this. What if the person is confused? What if you think for a moment saying, yes, I need that new phone, yes, I need that new car, and you're still confused? You might say to your friend saying, hey, I'm only 40% sure that I might buy that new phone. Or you might say, I'm just looking forward to it around 60% to buy that car or not. So you're associating a number, you're associating a percentage. That is when you bring in the entire world of probability. Now, if you do not know probability, do not worry, we're going to cover that and simplify it completely on another episode. But for this one, you have to understand at this moment that probability is used here. Now, when you take a look at probability, as I just mentioned, the answer for your probability ranges is always between 0 and 1. It is like a percentage. It's between 0 and 1, just like how percentages are between 0 and 100. Now, in this case, if the person cannot decide at all, and if the person is confused saying, I don't know if I should buy the car or not, they say, I maybe want to buy it, I maybe do not want to buy it. In that case, the probability is 0.5, or they have a 50% chance of buying it. So it's not this way either, or it's not yes completely and it's not no completely. It's exactly in the spot on middle, which is 0.5. Now consider another example here. Consider an example where you might ask the question saying, will the candidate win the election? Now, if you guys follow through the US presidential elections and most of the really big elections that happen everywhere around the world, all of these machine learning and AI based companies are the ones that are taking center stage these days, because they can thoroughly predict if a person will win the election or not, even without having a lot of details about it. Of course, since these elections come with a huge campaign that goes on for years together, your machine learning algorithm has a lot of data to predict if this person can win or not. So when you ask your machine learning algorithm, specifically a logistic regression algorithm, the question saying, will this person win? It can learn for a fact and it can give you very accurate numbers to eventually tell you if the person will win or not. Now, this would have been fun if anyone would try to run this on the last race of the Formula 1 season this year, because I am very sure no algorithm could have predicted that. Anyway, coming back to understanding about why you should not use linear regression. Now, I know a lot of you all are thinking at this moment saying, okay, big deal, just use linear regression there. If it works for all the predictions out there, it should work for this one. No, it will not work for this one. I'll tell you why. Because linear regression, you can have values between negative infinity and positive infinity. The cost of the ticket is not 1. It is not between 0 and 1. It can be thousands of dollars if you're going to the most fanciest of the fanciest amusement park out there. The thing about linear regression is there is no limitation to the value, the answer, or the output of the prediction that you can get. This is very important for you to remember. Now, why can't we use it? Because in logistic regression, we don't care about the value itself. We don't care about the price of the fuel. We care about if the amount of fuel that you have put in your car will take you to your destination or not. So we don't care about the fuel. We care if it is a yes or a no answer. We want to see if with that amount, with that price, with that fuel, can you go there or not. So all we are trying to do is we are trying to find out the probability of occurrence of that situation that you're looking forward to, rather than the value of that variable in that moment. This is a very important point that you guys should understand about why you cannot go about using linear regression. So in that case, you will have another question. Okay, so linear regression works between minus infinity and plus infinity, but logistic regression works between 0 and 1. So does this mean that we cannot predict anything which does not have the data between 0 and 1? Absolutely no, you can do it if there was a way to squish a lot of these numbers and bring it down to the range of 0 to 1. So is there a way to squish all of these numbers? Of course, the answer has to be yes to that, because we wouldn't have logistic regression if it weren't for it. Take a look at this particular mathematical equation. Now, as soon as I bring up equations, as soon as I bring up mathematics, for all you guys who might not really like mathematics, you might be wondering, oh no, we'll have to take a look at a lot of mathematics now. Don't worry, this is not a lot of mathematics. It is just one funky looking equation that you guys have to remember. Now, this is a beautiful equation. It's called the sigmoid curve equation, and I'm going to explain what it does in the most simplified manner for you guys. Just remember this equation. There's a lot of exponentiation that is happening. We have we have e power minus y. And if you have watched the linear regression equation, you will already know this particular equation from there. This is the simplified equation of a linear regression. Y is equal to beta naught plus beta 1 x1. If you don't know what this is, I highly suggest you take a quick second to pause this video, watch the linear regression episode, and eventually come back. Because if you remember this particular linear regression equation, we can actually take this entire process of regression and take it from it being linear all the way to it being logistic in a very simple manner. So we already know the linear regression equation, y is equal to beta naught plus beta 1 x1, and then we have the sigmoid curve equation that we are taking a look at. So here all you have to do is basically apply this sigmoid function on the linear equation curve. Now if you're wondering how to do about this, take a look at this. The sigmoid function has the variable y, and you can solve for y, correct? You can do a bit of mathematics, you can put it to the left, and eventually if it is exponential, you're gonna have log n, log to the base n, and you can make sure that y is on the left hand side and everything else is on the right hand side. You can do that. So basically here, even before you go about doing that, you have to directly substitute everything that you have from your linear regression equation and put it into y. And once you go about doing that, and once you solve the entirety of it, you're going to end up with one equation that looks like this: log of n p over 1 by p equal to beta naught plus beta 1 x1, and it goes on, because this entire thing that you look at is just we taking the linear regression equation, taking the y value from it, applying it for the sigmoid curve, and eventually whatever value the linear regression equation will see, it will squish it all down and bring it to the range of 0 to 1, and the final output that you see on your screen right now is the logistic regression equation. How cool is this and how simple is this? I wish a lot of people would actually convey logistic equation like this, but I found this to be a very nice intuitive way for you guys to understand this. So considering the sigmoid magic, this is exactly what it does, everything you're looking on your screen. Linear regression gives us this straight curve where we're trying to plot the data and give it meaning around this very straight line. But as soon as you convert it, as soon as you do that simple process that I just told you, we are basically converting this straight line into this beautiful S curve. That's the reason it has the name sigmoid curve. And here, as you can see, we are looking at a lot of importance between 0 and 1. Now observe this closely here. This graph basically is going on from 0 to 1, and the midpoint there is 0.5. You remember when the person was confused to buy a car, maybe or may not buy? This is the point there, 0.5, right? So we're going to take all the values. Instead of having multiple plots in a straight line, it's either going to be plotted at 1 or it's going to be plotted at 0. So how do you do that? It's very simple. What if the person who was buying the phone was only 40% sure that they wanted to buy a phone? If they were only 40% sure, it means that regardless of where your value was, we will bring it down to 0. If it is anything less than 0.5, bring it down to 0. And if the person is only 40% sure of buying the phone, there's a good chance the person will not buy the phone, correct? That happens there. Now, what if there was a person who was 80% sure or 90% sure that they would want to buy a car or a phone? You can easily predict that when someone says, I'm going to 90% do it, I'm going to 95% do something, that they will do it, right? So anything above 0.5 to 1 eventually means that they're going to do it. So any values that are there will get raised to 1. So you now understand how do you take a bunch of values. First of all, bring it to the range of 0 to 1. And after bringing it to the range of 0 to 1, even have an understanding of the confusion where a person might actually do it, not actually do it. Now, this is very important, not just for you as a learner, but for a machine to learn this, understand this process, and eventually help you with a lot of data. This is critical, and it works so simple and it's so beautiful at the end of the day, because there are many beautiful applications that come out of this simple concept that we discussed. It's very popular in the world of medicine and finance. In the world of medicine, it is actually used to predict the effectiveness of a drug based on a person's health condition. You can actually find out what is the amount of medicine that you have to give for the person to recover really well. And I absolutely love everything the world of machine learning and medicine do together. We're going to create another episode on that. It's going to be a very exciting one. Make sure you guys are tuned for that. And then the other application right now that you guys, I bet every one of your credit card companies use this. It is a way in which they understand whether a person can fulfill your credit score or not. Now, your credit score might be very good and you might have a large amount of credit that you can pull from your credit card. But how does the bank know that you will guarantee it in fulfilling it back? They don't. So they take a risk in giving you all that capital. But that risk is not just a random risk that they calculate. They go about using a lot of machine learning, a lot of artificial intelligence to find out the probability with which you can actually fulfill the loan versus you taking off their credit money and you running away from them. A lot of the world today uses logistic regression, and this is among one of the most important algorithms for the year 2022 as well. We've discussed that in the top 5 machine learning algorithms for 2022 episode. If you haven't had a chance to take a look at that, I highly suggest you guys take a look at that. And ladies and gentlemen, with this, I definitely want to tell you guys that there are a lot more simplified episodes that are coming your way, wherein we're going to take up these really complex words: logistic regression, linear regression. We're going to pick up many of these beautiful algorithms, simplify it down to its absolute basics, so that all of you all who are watching this can have complete understanding and thorough understanding of that. So to make sure you guys never miss out on that, do take a second to hit that subscribe button, because if you do hit that subscribe button and the bell icon next to it, you guys will be the first ones to get notified as soon as I put out these episodes, and I bet you guys are looking forward to that as well. So ladies and gentlemen, thank you so much for tuning on to this episode of Learn with Anirudh. I'm super excited to catch you guys on the next one. See you.